All right, so we had our last objective so that you could hopefully memorize the polyatomic ions. So if you look at your notes, polyatomic ions are groups of nonmetals that form a cohesive ion. Okay, so phosphate is phosphorus and oxygen. Nitrate is nitrogen and oxygen. So if a polyatomic ion is present in a compound, okay, the compound is known as a ternary compound. All right, so the first one was binary compounds. So we had a single metal with a single nonmetal. So we were only talking about two elements. Now that we have more than two elements, let me find my pen real quick. Now that we have more than two, it's known as ternary instead of binary. I just misspelled that. So Ternary. You don't need to know that. It's not going to be on a quiz or anything. But ternary as opposed to binary. So binary means two, and ternary I think just means more than two. So this means there are more than two types of elements present, which means they do not end in the suffix "ide." So anytime we have a binary compound, doesn't matter every single time in chemistry, which you can hardly ever say that, there's always exceptions. But binary compounds always end in "ide." Okay? The one exception is the single polyatomic ion that ends in "ide," which is hydroxide. Okay, so if you have hydroxide in a compound, it will end in "ide," but it's not like phosphide or nitride or oxide or chloride or bromide or fluoride. So hydroxide is the only polyatomic ion that ends in an "ide." Okay, so if we go to this first one, now we're kind of just mixing stuff up. So I have iron, all right? So I know I'm going to write iron. And then based on the last podcast, iron is in the middle, okay? So it's going to require a Roman numeral. So I'm not going to write the Roman numeral. I'm going to leave a space there. And then we need to write NO3. So NO3 is not like nitrogen, oxygen, or nitroxide or something like that. But that has a name. So that NO3 is in parentheses. And we have that thing, and that thing is called nitrate. So we have some kind of iron nitrate. So just like we did in our previous podcast, if we don't know the charge of our metal, so those metals in the middle, those transition metals, we will always know the charge of the negative ion portion, okay? So nitrate is a -1. So -1 times 2 is -2, which means the anions, or the negative ions, are contributing a -2, which means the cations, or positive ions, must be contributing a +2. So in this case, iron has to be contributing a +2 charge. And because there's only one iron, its charge must be all of that +2. So this is really iron, Roman numeral 2, nitrate. And the way we would say that is just iron 2 nitrate. Our next one is Mg. All right, so, oh, yes, Ms. Brigitte, you're so nice. That is not one of the metals in the middle, so it's not going to require a Roman numeral. It's just going to simply be magnesium. So we have magnesium. And if we have magnesium, we don't have to figure out Roman numeral. We just say it like it is. So magnesium, and it's with PO4. And hopefully you know that as phosphate. So we have magnesium phosphate. All right, last example, CuSO4. So Cu is copper. And we're just going to put it right up here. So I've got copper. It's another metal in the middle, Burkitt. All right, so I'm going to leave a space. And then we're going to write, who is it, SO4 this time, so sulfate. All right, and we have to figure out what is the charge that's going to go right here after my copper. So if we go back to the right-hand side, we see we have a sulfate. So what charge is sulfate? It is a +2 charge. And how many sulfates do we have? A common mistake students will make here is they'll go, oh, we have 4 of them. So they'll do +2 times 4 and get a +8. That is not the case, though, because that O4 means it's sulfate. Okay, if it was SO3, it would not be sulfate, it would be sulfite. So that is not how many we have. Really, if we kind of think about this in terms of parentheses, we have 1 sulfate. Okay, so my sulfate contributes a +2 charge. I'm sorry, a -2 charge. This is negative. I've been lying the whole time to you. So sulfate's a -2 charge. So what does my copper contribute? It must contribute a +2 charge. So over here on my Roman numeral, we have copper, Roman numeral 2, sulfate. Okay, and then kind of likewise, Not too bad if you have your polyatomic ions memorized. If you don't, this is a disaster, just a train wreck waiting to happen. But if you have them memorized, it's really, really easy, very similar to the stuff we've been doing already. So on this bottom one, I have copper 1 carbonate. So I know copper is Cu. This particular copper is +1, and it is with carbonate, so CO3. And this whole thing is a -2. So it's the least common multiple of +1 and -2. It's a 2, so I'm going to put a 2 right here, and I'm not going to put anything on my carbonate. If you would like to put these just in parentheses automatically, all right, and don't worry about putting a 1 outside, you might do that. For some of you, that will be easier, just so that you know that this 3 is not really a subscript saying how many carbonates we have. That 3 is telling us we actually have a carbonate. Okay. The next one is silver nitrate, so I'm going to write Ag. Ag is one of those metals in the middle, but it's a bing, bing, bing. So it's a +1 charge. That's why it doesn't have a Roman numeral. And it is with nitrate, which is NO3, which has a -1 charge. Ooh, my charges are balanced. So AgNO3. And then lastly, we have one cation that is a polyatomic ion, and that is ammonium. All of our others have negative charges. So phosphate, nitrate, carbonate, chlorate, all are negative, except for ammonium. So I have ammonium with sulfate. So this is still a ternary compound, even though there's 4 elements instead of 3. Okay, and ammonium is a +1 charge, sulfate's a -2 charge. So again, you might do like parentheses around these guys. You don't have to. We only need parentheses if we have more than one of them. But I'm trying to get the least common multiple of +1 and -2, and that's a 2. So I'm going to put a 2 on my ammonium, and I need a 1 on sulfate. Again, you don't need to write a 1 there, but really it would just be ammonium in parentheses followed by SO4. Okay? So that is polyatomics in the midst of compounds. If you have them memorized, it's really no different than what we've been doing so far.